Hello, Vanakkam. I am Sujit. Welcome to Physics 2020. So, today in this session, we are going to learn projectile motion in an inclined plane. So, in the previous sections, we have studied and we have solved the numericals in projectile motion in a horizontal plane, projectile motion at a certain height. Okay, so the theory we have discussed: what is projectile motion in a horizontal plane, what is the projectile motion at a certain height. So three different possible cases. If a projectile is projected horizontally at a certain angle below the horizontal, at a certain angle above the horizontal. Okay, so these are the things we have studied in the previous sections, and we have solved 10 numericals in each section. Okay, so in this section we are going to learn, that is, projectile motion in an inclined plane. Projectile motion in an inclined plane. Inclined plane. Okay, very important topic. So what are the what are the things we have studied? That is projectile motion in a horizontal plane. Projectile motion in a horizontal plane. So this is a horizontal plane. Okay, horizontal plane. So from here a projectile is projected, okay, at an angle theta with the horizontal, with the initial velocity u. So it makes a trajectory, okay, trajectory like this. So what is the horizontal initial velocity? That is u cos theta. And what is the vertical initial velocity? That is u sin theta. Okay, sin theta. So this is the maximum height of the projectile, and this is the horizontal range. Okay, horizontal range. So this is the projection in a horizontal plane. So in second one we have studied, that is projection at a projectile motion at a certain height. At a certain height. So here it is like this. So this is a tower, okay, tower of height capital H. So from here on projectile is there. So that is which projected horizontally, okay, horizontally with the initial velocity u. Initial velocity u. So it makes a trajectory like this, the path followed by the projectile, okay, like this. So this is the first case we have studied. Then after that we have studied, that is so this is the horizontal. So projectile is projected at an angle theta above the horizontal, so with initial velocity u. And if a projectile is projected, that is at an angle theta below the horizontal with the initial velocity u. So these are the things we have studied in the previous sections, okay, previous sections, and we have discussed, that is numericals also. Now we are going to study, that is the projectile motion at an inclined plane, okay, at an inclined plane. So this is a inclined plane. Okay, certain angle theta. So this is an inclined plane. So which is inclined to the horizontal at an angle theta. Okay, at an angle theta. So in this two types of projectile motion we have to discuss. Suppose the first case is one projectile is here, which is projected with initial velocity u. Okay, initial velocity u at an angle alpha. So different angles. So here that is the horizontal inclined plane is which makes an angle theta. So that's why we are taking this angle as alpha. Okay, alpha. So it is like this. Okay. So it makes a trajectory. Okay, path of the projectile is like this, and finally it reaches the point here. So this is the maximum height attained by the projectile. So the next case is, so this is a inclined plane which makes an angle theta. Okay, theta. Projectile is projected from here. Okay, projected from here at an angle alpha with initial velocity u. It makes a trajectory like this and finally reaches the point here. So this is the maximum height of the projectile. Okay, projectile. So the two cases, that is projected from bottom to up. Okay, bottom to up. So second one is projected from top to bottom. Top to bottom. So bottom to top and top to bottom. So these are the inclined plane, that is the projection at an inclined plane. Clear? So this is an inclined plane which makes an angle theta. Okay, inclined plane. So we have to project. So the first case is a projectile is projected from the bottom of the inclined plane and to the top of the inclined plane. So the second one is at the top of the inclined plane, one projectile is projected with initial velocity, with a certain initial velocity with a certain angle. So it reaches the bottom of the inclined plane. So these are the two things we have to discuss in this projectile motion and inclined plane. So first of all, before coming to this projectile motion in an inclined plane, you should learn the basics of projectile motion, that is horizontal projection and projection from a certain height. That is the fundamental or basics of projectile motion. So you should learn them from in physics 2020. So I have posted the video, that is I have taught the theory and numericals of, that is what projectile motion in an that is horizontal projection and that is projection at a height. So you learn that before coming to this inclined plane. Then only you can understand, that is you can follow this inclined plane projection. Okay, inclined plane projection. The fundamentals or basics of inclined plane projection is that one. Okay. Projected, so inclined plane. Okay, projected from bottom to top. Bottom to top. First case. Okay, so consider this is a horizontal plane. Okay, horizontal plane. So in this we have made the projection, okay, studied, that is horizontal projection, projectile from a horizontal plane. So this is, consider this is a horizontal plane. So what is the x-axis? This is the x-axis and this is the y-axis. This is the y-axis. So x-axis and y-axis. Right. So one projectile is here. So which was projected with initial velocity u at an angle theta. At an angle theta. So it is moving. The projectile is moving in the xy plane. So this is the x plane. Projectile is moving in the xy plane. Xy plane means this is the xy plane. Okay, that is two-dimensional motion. The object undergoes two-dimensional motion or xy plane. So the object is moving in xy plane. Both horizontal motion, otherwise we can say that is the object projectile undergoes two types of motion, horizontal motion and vertical motion. Okay, vertical motion. So this is the thing we have studied. So now here, so we are considering that is inclined plane. Inclined plane means this is the inclined plane. So the plane is inclined. So not horizontal, inclined. So inclined at an angle theta with the horizontal plane. Okay, horizontal. Yes. Right. At an angle theta. So this is our inclined plane. Okay, inclined plane. So from the bottom of the inclined plane we are projecting on. The projectile is projected. Okay, projected. Okay, projectile is projected at an angle alpha. So the angle is different. So that is, we have taken the angle of inclination with the horizontal, we have taken theta. So this angle, that is the projection angle we are taking, that is alpha. Okay, alpha. So this is the trajectory of the projectile and it reaches this point. So this is the maximum height of the projectile. Okay, maximum height of the projectile. Now the question is that what about the x-axis and y-axis here? So in the inclined plane, what about the x-axis and y-axis? So in the initial case we have taken, that is the x-axis here. Okay. Now where is the x-axis and y-axis? Actually initially, that is, we have imagined that is the horizontal plane. So the x-axis is through the horizontal. Now this horizontal plane is tilted, that is inclined plane at a certain angle. Okay. So that is, we have rotated that plane to a certain angle from the horizontal. So that is, we can also rotate, that is the x-axis and y-axis. Okay, through this plane. So we are considering that if we have considered that is the x-axis through this horizontal. Now we can imagine that is the x-axis along the inclined plane. Okay, along the inclined plane. So the x-axis is through the inclined plane. This is the x-axis. That is, we can, that is, rotate x-axis and y-axis. Okay, y-axis through an angle theta. Through an angle theta anti-clockwise. Very important. We can rotate that. Okay. So the x and y axis, that is, it depends on the frame of reference. Okay, frame of reference. So if the x-axis is rotated through this means, so correspondingly y-axis also, that is x-axis and y-axis are mutually perpendicular. Okay, mutually perpendicular. So the correspondingly y-axis also rotate. Okay, y-axis also rotate. This is our y-axis. So x-axis rotated through an angle. Okay, through an angle. So y-axis correspondingly the y-axis also. So if this is the x-axis, y-axis is like this. So the x-axis has rotated through an angle theta. That much angle the y-axis also rotated. So this is the y-axis. Clear? Very important. First thing, that is in projectile motion. Okay, that is in projectile motion in inclined plane. Okay, fixing the x-axis and y-axis according to the inclined plane. Now, what is the horizontal component of velocity and what is the vertical component of velocity? So, suppose now x-axis, this is the x-axis and this is the y-axis. So, now the projectile is projected at an angle alpha with an initial velocity u with the x-axis. So, the horizontal component of velocity, initial horizontal component of velocity, that is u cos alpha. What is the vertical component of velocity? That is u sin alpha, u cos alpha and u sin alpha. Okay. So what about this u cos alpha and this u sin alpha? That is, the projectile is projected at an angle alpha with the velocity, initial velocity u. So the initial horizontal component of velocity, that is u cos alpha, that is initial vertical component of velocity, that is u sin alpha. Clear? So what about the acceleration? Acceleration here. So when we consider the horizontal plane, that is the acceleration is acting like this g. Am I right or not? G. When we tilt this plane in an inclined manner, okay, inclined manner. So whether this acceleration will act like this, okay, acceleration initially when this is a horizontal plane, okay, so the acceleration will be like this. No. So acceleration always acts, that is perpendicular to the whether it is a horizontal plane or vertical plane, the horizontal acceleration direction won't change. It is acting always towards the earth, okay, towards the center of the earth. Okay, so when we consider this point, okay, this point, so the acceleration due to gravity is acting like this. Am I right or not? So g. Okay, g. So this now, so what is the axis perpendicular to x-axis in the downward direction? Okay, downward direction. So this is the positive y-axis. So what about the negative y-axis from this point? It is like this. That is 90 degree. Okay, this angle is 90 degree. So this angle is theta. So this angle is 90 degree. Okay, so this is 90 minus theta. Am I right? 90 minus theta. So this angle is, this much angle is 90 degree. So this is 90 minus theta means this is theta. Okay, theta. Clear? So now what about this component? So this is a vector, okay, vector. So which makes an angle theta with this. Okay. So what about this component? That is g cos theta. Okay. So what about this component? That is g sin theta. G sin theta. G sin theta. Clear? G sin theta. So otherwise this component we can extend here. Okay, so this component, it is G sin theta. So these are the components of, that is inclined plane. Okay, inclined plane, very important. Okay, now, so this is a x-axis and y-axis. So this is a x-axis and this is a y-axis. Okay, so an inclined plane. So I am drawing this x-axis and y-axis, that is in this way. Okay. So projectile is here. So from projected, that is with initial velocity u, so at an angle theta. Okay, at an angle theta. So the projectile makes a trajectory like this. Okay, trajectory like this. So the horizontal component, initial horizontal component of velocity, that is, so which makes an angle, that is alpha. Okay, alpha, that is u cos alpha. Okay, u cos alpha. What is the vertical component of velocity? That is u cos alpha. So what is the vertical component of velocity? That is u sin alpha. Okay, u sin alpha. So G is acting two components, that is acceleration. Okay, acceleration in the negative y-axis, that is g cos theta, and this is the vertical component of acceleration. Okay, vertical component of acceleration. What is the horizontal component of acceleration? So horizontal component of acceleration is acting like this, that is g sin theta. G sin theta. Clear, Kadam? Okay, so the here also, that is the projectile undergoes two types of motion. Okay, projectile undergoes two types of motion. What is that? Is horizontal motion, horizontal, and vertical motion. Okay, vertical. So the combined effect of horizontal motion and vertical motion also, that is in all the projectile motion, that is the combined effect of horizontal motion and vertical motion, whether it is a horizontal plane or inclined plane. Okay, the projectile undergoes two types of motion, very important, that is x horizontal motion, that is the motion through x-axis. Vertical motion, the motion through, that is y-axis. Okay, y-axis. Okay, y-axis. So what is the initial horizontal velocity? Initial horizontal velocity, that is u cos alpha, that is ux is equal to u cos alpha. What is the initial vertical velocity? That is uy, u sin alpha. Okay. What is the horizontal acceleration? Okay, horizontal, in the horizontal direction, what is the acceleration? Yes, this is the acceleration, that is acceleration in this direction, that is a retardation. Okay, retardation which is acting against the velocity. Okay, so g x, or acceleration in the x direction, acceleration in the x direction. So I am writing that is ax is equal to minus g sin theta. It is acting in the negative x direction. Okay, negative x direction. That is retardation. So minus g sin theta. So in the initial projectile, in that horizontal projection and projection at a certain height, there is no acceleration. Very, very important. That is, we have studied, that is, acceleration is 0. The horizontal acceleration is 0. So that's why the object is moving with a horizontal constant velocity. Constant velocity from the point of projection to the that is final point. Okay, final point. It has the constant horizontal velocity. In the horizontal direction there is no acceleration, but here acceleration is there. Okay, acceleration is there. It is a retardation. So ax equal to minus g sin theta. So what is the vertical acceleration? Okay, vertical acceleration ay is equal to, so it is in the negative y-axis. Okay, negative y-axis, that is minus g cos theta. Okay, minus g cos theta. Okay, so initial velocity in the horizontal direction u cos alpha, initial velocity in the vertical direction u sin alpha, acceleration in the horizontal direction minus g sin theta, acceleration in the vertical direction ay is equal to minus g cos theta. Okay, cos theta. So what is the final velocity? That is vx. Final velocity in the horizontal direction. Okay, horizontal direction. So v is equal to u plus after a certain interval of time. Okay, certain interval of time t. Okay, t. So v is equal to u plus at. So we can write what is u, that is u cos alpha minus, okay, minus here acceleration negative, minus gt. Okay, minus what is the acceleration? So acceleration is constant. Okay, acceleration is throughout the motion, that is acceleration is constant. So minus g sin theta into t. Okay, minus g sin theta into t. Then what is the final vertical velocity? Vertical velocity in the final vertical velocity vy is equal to initial vertical velocity, that is u sin alpha minus g cos theta into t. So this is the final vertical velocity. So whether this acceleration is varying or constant? Acceleration is constant only, that is minus g is a constant value, that is 9.8. Sin theta never changes, that is the angle of inclination, it never changes. Okay, never changes. So therefore acceleration is equal to constant, minus g sin theta, constant value, minus g cos theta, that is also constant value. So both vertical acceleration and horizontal acceleration is constant, because g is a constant. Then sin theta or cos theta values are constant, because theta never changes, theta is constant here. So that is the angle of inclination. Okay, so when you analyze this, when you study that is projected motion, that is projectile motion in an inclined plane. So these are the basic things you have to know from that is what? Projection at a horizontal plane or projection from a certain height. Okay, height. So these are the preliminary quantities. Okay, preliminary quantities. So understand that that is when the projectile motion in an inclined plane means it also undergoes, that is, two types of motion, horizontal motion and vertical motion. So we have to find, first we have to find, that is the horizontal component of velocity and vertical component of velocity, initial velocity and acceleration. So here acceleration is also divided into two components, that is horizontal component and vertical component. Very, very important. Okay.